Identify and graph integers. The set of integers consists of any number from the set -3, -2, -1, 0, 1, 2, 3, and it goes on in both directions, negative and positive. This includes natural numbers, which are your counting numbers, 1, 2, 3, 4. Their opposites, -1, -2, -3, -4, and 0. Positive numbers are numbers that are greater than 0. Negative numbers are numbers that are less than 0. So here we have our negative numbers. Okay. And we have our positive numbers. And we have 0. Circle all integers from the list below. Remember, it's any number you would see on a regular standard number line. Do you see -2 on this number line? Yeah, I do. That is an integer. So let's go ahead and circle it. 1/2? Nope, I don't see that. This symbol we'll talk about a little bit later is pi. It is not on a number line. Here we have a repeating decimal. That little bar right here means repeating. Also not on a number line. 0. Yep, there's 0 on this number line. I have a decimal that goes on forever, has a pattern, but no repeating. It is not on this number line. -124. Now, it's not currently on this number line, but if I keep going, that's what this arrow means. If I keep going, -124 will show up. Similarly, you have the number 1000. If I keep going and I keep counting, I will get to 1000. -99, also an integer. 3.14, it's a decimal. It's not an integer. -2/5. I can't reduce or simplify -2/5. It's a fraction, therefore not an integer. What do you think about this one? Yes or no? 1,234,567,890. And again, that's negative. What do you think? Yep, that's an integer. Now here we have a fraction, but I can reduce it. I can actually divide by 10 on the top and the bottom, and I get 3/1, which is the same as 3. And 3 is an integer. 12/16. I can reduce this one as well. I can divide by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. 3/4. It's still a fraction, therefore this is not an integer. On this next one, -27/3. I can divide by 3, and I get 9/1. Let's bring that negative over. And -9/1 is the same as -9. This is an integer. List 3 examples of non-integers. So let's not use any of them that are up there. 3 examples of non-integers. Well, 1/4 is not an integer. It's a fraction. -0.2 is not an integer. It's a decimal. And let's do -7/9 is also not an integer. Now let's write integers to represent each situation. Gain 12 pounds. Gain, that means positive. Or I'm sorry, this says pencils. Gain 12 pencils. So that's a positive 12. Number 2, lose $7. I'm losing money, therefore it's -7. 8 degrees above normal. Above has a positive connotation, so this would be a positive 8. Profit of $27. Profit is where you make money. So if you're gaining or making money, that is a positive 27. 2 inches below. Below means underneath, so we would call that a negative 2. What about number 6? Gain of 51 yards. Think about that one. A gain of 51 yards. Okay, that would be positive 51. 200 feet below sea level. Think about it. That would be negative 200. A loss of 34 pounds. What do you think? Negative 34. Okay, let's take a look at the next page. Identify the integer at each point on the graph below. Okay, so A is here. If you notice, this is negative 15 and this is negative 10. So let's start at negative 10 and let's count down, which really, it's kind of like counting up, but they're negative. So we're really counting down. So negative 10, negative 11, negative 12, negative 13, negative 14. B is in between the negative 10 and negative 5, so I'm going to start at negative 5, negative 6, negative 7, negative 8. Try letter C. Start here at negative 5. That would be negative 6. D is a nice easy one. It's on the 0. E, this time I'm going to start at 0 and go right. 1, 2, 3, 4. And then letter F is simple. It's 15. Now let's go the other way. We have integers. Let's graph them. 7, it's positive 7. So let's go ahead and go to 0. Where would 7 be? Well, here's 5. I can jump to 5, 6, 7. And I want you to put an A above that. I'm going to go ahead and make these a little bit bigger. There we go. B is negative 4, so start at 0. It's negative, so I need to go towards the negative numbers. Let's count. Negative 1, negative 2, negative 3, negative 4. And we're going to label this with B. C is 0. That's easy. I just put a point on 0. Notice how many points are on the number line. Not above it, not below it, but on the number line. And I'm labeling. Try letter D. It's 12. Start at 0. Find where 12 would be. Okay, hopefully you placed it there. That's letter D. And E is negative 10. Give that one a try. It's negative, so start at 0. Which way are you going to go? Here's your E, negative 10. Okay. What is the distance, which is only a positive number, between A and D? You're just going to count the number of spaces between A and D. So start at A. 1, 2, 3, 4, 5. It's always positive. It's 5 spaces away. Okay. B and E. Give that one a try. Count the spaces between B and E. 1, 2, 3, 4, 5, 6. And then go ahead and try D to E. D is here. E is all the way over here. You should have gotten 22. Now let's compare integers. We're going to determine if each set of integers is greater than, less than, or equal to one another. Remember, negative numbers are smaller than positive ones. So negative 1 and 0, negative is smaller. It would be this symbol. You can put the symbol in the little box if you want as well. Number 19, -5, +5. What do you think? Yeah, 5 is definitely bigger. Positives are always bigger than negatives. Number 20, 17 and 16. They're both positives, so which one's bigger? 17 is greater than 16. Number 21, -10 and -10. Those would be equal. Number 22, we have a fraction here. Can we reduce that? Well, 15 thirds, I can divide by 3, and I get 5 over 1, which is the same as 5. So I'm really comparing 5 and -5, and 5 is greater. Number 23, 10 and -100. 10 is positive, therefore 10 is greater than -100. You have to be careful with negatives like on number 24. Think of the number line. You can scroll up if you want. -12 and -9. -9 would be here. -12 would be here. The number that's on the right would be the larger number. So even though it seems wrong, -9 is in fact bigger. So -12 is less than -9. Number 25, 10 halves versus 5. Well, 10 halves we can divide by 2, and we get 5 over 1, which is 5. So we're really comparing 5 and 5. What would that be? Equal. Okay, we have two negatives again. Think of that number line. If I have 0 here, -1, -2, I have to keep going to get to -8. So -2 is bigger because it's further right on the number line. So -8 is less than -2. Try the last three on your own. Okay, 0 is greater than -11. 22 is greater than -2. -4 is greater than -5.